All right, so let's look at some problems as far as simplifying expressions. I want to look at number 1 here. Okay, so we're going to look at number 1 here. So the thing you have to look at in this specific problem is the fact that there is now a 0.03x, I'm sorry, 0.3x, and a 0.6x. Those are going to get combined together like we've been doing. This is new though, this plain 3 by itself. That's what you call a constant. The constants are treated just as if they are a different letter. So the 3 cannot be combined with the x's, so it's going to be on its own. So what we would do first is we're going to combine the two x's. So 0.3 plus 0.6. So we combine those coefficients and we get 0.9x. Then we're just going to simply tack on the constant, or the 3. That would be your answer. So for number 3 here, let's try this one. So I want to look at 0.8 minus 0.2 because these both have the letter x. 0.8 minus 0.2 is 0.6x, and then we just keep our constant of a minus 5. So again, you can't combine this constant with the letters. That's illegal. You want to treat the constant as if it's its own letter, or a different letter. Let's look at these. So in this case, number 5 here, 0.3p plus 0.2p plus 0.4p. Well, the good news is they're all the same letter. So we will just do 0.3 plus 0.2 plus 0.4. We're going to add those together. So 3 and 2 makes 5, plus 4 is 9. We have our decimal and a 0, and then we'll put the letter p. So 0.9p is the answer for that one. Let's look at our next one, because this is going to be a little bit different because of the fact we have some fractions with different letters or different denominators. So the good news is they're all the same letter, so we're just going to combine the fractions. So this would be like if we had 1/3 plus 1/6 plus 5/12. So a number of different ways to attack these problems. I personally am going to just focus on 1/3 plus 1/6. Now, you can boom boom pow this. So that would be 1 and 6 is 6. And then we could say 3 and 1 is 3. Over 3 and 6 is going to be 18. So that becomes 9 over 18, which reduces to 1/2. So I'll go down here, I'll put 1/2 plus, now we're going to bring this guy down here, 5/12. Now you could boom boom pow here, but I personally notice 2 and 12 are my denominators. So I'm going to do a common denominator here. So I know 1/2 can be rewritten as 6/12, because 6 is half of 12, plus 5/12, which would equal 11/12, and then we bring our letter y, because the letter y comes down and is applied. Remember, you could put it on the side or the top, but never put it in the bottom. Let's look at this next one. So we have 7x plus 6 plus 4x. So I like to underline all my letters. So we're going to combine the 7x and the 4x, but the constant is going to be by itself. So 7 plus 4 would be 11x, and then we're going to add a 6, and the constant stays at the end. For our next one, we're going to look at the 1.8 and the negative 0.7 get combined. So that's 1.8 minus 0.7, which is 1.1, and we want to give the letter to it. So that would be 1.1x minus 0.6, or the constant. So this number without a letter just gets put at the end. You always put your constants at the end or all the way to the back. All right, so we've got a number of problems here that we're going to be working on. So let's first look at 13. notice there's 2x plus 4x plus 7y. So I know that the 2x and the 4x can be combined, but the 7y cannot be combined with those because it's a different letter. So 2 plus 4 is going to be 6x. Then we'll say plus our 7y. This would be your answer right there. That's it. Notice also I put them in alphabetical order. I put my x, then my y, because of the alphabet, x, y, z. If you have a constant, the constants would go always at the end. So that's that one. Alright, so let's try the next one. We're going to look at this one right here. So that would be 9x minus 7x plus 3y. So we have our x values. I like to put those in a box. Then I'll change the color for the y. So if you have highlighters, highlighting is a great technique to use here. 9 minus 7 would just be 2x. And then we put plus our 3y. And that would be your answer there. Those don't combine anymore because you can't combine the two different letters together. Alright, so let's move on to the next one, 17. So 2.3a minus 1.8a plus the 3.5b minus 2.7b. And there is a decimal there. Alright, so this is an a, but negative 1.8 is an a, 3.5b, negative 2.7b. So we're going to combine the two a's. So this would just be 2.3 minus 1.8, which would be borrowing. So 13 minus 8 is 5. So that looks like it's going to be a 0.5a. And you can also just put 0.5a. And then we'll do 3.5 minus 2.7. So that's a 15, 1, it's an 8, a decimal. I'm sorry, make that a 2. So 0.8 or positive. So we'll go positive 0.8b. Then this would be your answer. So again, you're combining your two a's, your coefficients to get 0.5, put the letter. Then your two coefficients of your b, put the letter. And that's it. Let's erase all these. Alright, so the last one, the fractions. So we'll do 3/5 a plus 2/5 a. And then we'll rewrite the b's. So the 6's and the b's look the same, but they're different. Let's focus on these right here, and then these. Alright, for this one, so this is just 3/5 plus 2/5. Same denominator, same letter. 3 plus 2 is 5 over 5a, which is just 1a, but we know we don't write the 1, we just put an a. For the second part, so if I draw a little line to separate, we're going to look at 1/6 plus 1/6. So that's 2/6, which reduces to 1/3. So we're going to add 1/3 in our letter. So we can combine these simply because the denominators are the same and the letters are the same. So this answer would be A plus 1/3 B. It looks a lot more difficult than that problem actually is.